All right, so the first section we're going to review is exponents, then we'll go into radicals. This is what we did from week 6 through week 9. So the first one we did was 1 through 5. We managed to do all of that in a one lesson and one worksheet. Same thing here. We're going to go 6 through 9 in one lesson today and one worksheet next class. So first things first, adding and subtracting. Notice here in red, I write in words what the rule is. So exponents do not change. So when you add or subtract, all you're doing is collecting like terms. The exponents do not change. So the easiest way to explain that is just asking a random question to any student. What is 2x plus 3x? 5x, right? Most of you will say 5x without even thinking about it. Now you can think back at what you did to get 5x. We added the numbers, but what happened to the x? It stayed the same, did not change. So you do it without even thinking, but once the exponent gets bigger, you get confused. No, it's the same thing. Add the like terms, the exponents do not change. So in this case, 3x to the third minus 7x to the third is negative 4x to the third. And then this one is not a like term, so it has to come down next to it. That's it. Now, don't do the Oyo yet. We're going to do these two pink examples, and then you do the Oyo on your own. So here we go. On the first one, the numbers follow number rules. So 10 times 2 times negative 3, that gets multiplied. But the rule with exponents is exponents get added. So I'm going to multiply the numbers. 10 times 2 is 20, times negative 3 is negative 60. That's a normal process because they're not exponents. Now we get to add the exponents because the rule is add the exponents when you multiply. So 2 plus 1 plus 4 gives you x to the 7th. Don't forget that 1. If it doesn't have an exponent, you put a 1 on there. You have a question? Now look at this next one over here. On the next example, instead of being one term on each parentheses, you have two terms on each parentheses. So let me remind you how to distribute two binomials. 2x times 3x and 2x times 4. That's the first thing that gets distributed. But remember the rule of multiplication. Add the exponents. So if you don't see an exponent, there's an imaginary 1 there. Don't forget to add it. So 2x times 3x is 6x squared. 2x times positive 4 is positive 8x. There's no exponents to add there because the 4 had no variable or exponent. Now we distribute the negative 5. Negative 5 times 3x is negative 15x, and negative 5 times positive 4 is negative 20. Whenever you distribute two binomials, the like terms are in the middle. So here in the middle, we have 8x minus 15x, which is negative 7x. And the first and last term just come down. So this comes down to the front, 6x squared, and then the minus 20 comes down at the end. This is your answer. Now, I want you to try the two orange questions on your own. Go ahead and try it. I'll give you, please pay attention. I'm going to review both examples. So on the first one, make sure that you write the coefficient. The coefficient next to the first x to the third is a 1. So because those are the same variable and the same exponent, they're like terms. They can be put together. So 1 minus 10 is negative 9, and x to the third does not change. So negative 9x to the third. Now, on this example, I'm going to do it up top to have more space. Please pay attention because this is definitely an important question. 3x times x squared is 3x to the third power. Why? Because 3 times 1 is 3, and x1, x2 is x3. You add exponents when you multiply. Now we do the same thing for the rest. 3x times negative 6x is negative 18x to the second power. 3x times positive 2 is positive 6x. We got three results. Now we distribute the positive 2 to those three numbers, so we get three more results. 2 times x squared, positive 2x squared. 2 times negative 6x is negative 12x. And 2 times positive 2 is positive 4. Now look at the like terms in the middle. We have negative 18x squared plus 2x squared, which gives you negative 16x squared. And now you have the x's. Positive 6x minus 12x is negative 6x. Now, same thing happens with the first and last number. They just come down. So 3x to the third comes down, and the positive 4 at the end comes down. This is your answer. Any questions? Please ask. All good? We move over? Now, on the next page, we're going to review the power rule and the division rule. For the power rule, how do you know it's a power rule? When there's an exponent touching a parenthesis on the outside. That tells you that you have to multiply the exponents. So be careful, because the mistake people make here is they forget that the 6 has a 1 exponent also. If you don't see an exponent on the 6, you put a 1 there. That 2 exponent does not belong to the 6. That 2 exponent is right on the x. So that tells you the 6 has its own exponent. So now, what's the rule when we see that exponent touching the parentheses? We multiply with all the exponents inside. So 2 times 1 gives you 2, and 2 times 2 gives you 4. Now, 6 to the second power is 6 times 6, which equals 36. So my answer is 36, x to the fourth. This? This one? This one? The one that I just did? Move on. Look at this next example. Be careful, because this is one that people make a mistake on. Okay? Look over here. Is the 4 outside of the parentheses? No, that 4 is not outside the parentheses. Only the ones that are outside of the parentheses get multiplied. So 3 times 2 is 6. Now that is what gets multiplied to the 4 and to the imaginary 1 on the 10. So what's my answer going to be? 10 to the 6th power, because 6 times 1 is 6, and x to the 24th power, because 6 times 4 is 24. Now, 10 to the 6th power is 10 million. X to the 24th. Now, how did I do that so quick? A 10 with an exponent, that's how many zeros you have on the 10. So 10 and 6 zeros. You with me? It's not that difficult. Don't get crazy because it's 10 million. All right, ready? Now let's go to the division side. With division, the rule is the opposite of multiplication. When you multiply, the rule is add exponents. But when you divide, the rule is subtract exponents. Now, same process. Numbers follow number rules. So 10 divided by 2 is going to be 10 divided by 2. 2 over 10 can't be done. So this can only be simplified. So look at the difference between how I solve both. First of all results go on top. So 10 divided by 2 equals 5. I put it on top. That's how it works. And now x to the 7 divided by x to the third is x to the fourth, because 7 minus 3 is 4. Now, do you see any negative exponents there? No. So that means that is our answer. So 10 divided by 2 is 5. 7 minus 3 is 4. Subtract exponents. Now look at the second example. 2 divided by 10. That can't be done without getting a decimal. So you cannot divide it. All you can do is simplify it. 2 over 10 simplifies to 1 over 5. And now subtract the exponents. 5 minus 1 equals x to the fourth. All results go on top. Now, you can't leave your answer like that. There's two ways of answering this. The first way is x4 over 5, because that imaginary 1 touching the x, you don't have to write it. Or you can just write it completely next to the fraction like this. 1/5 times x to the fourth. Any questions so far? What? The 5 doesn't get touched because it's a fraction that couldn't be divided. It was only simplified. If you can only simplify it, then the numbers stay where they are. 1, 5. So if you don't know how to simplify, just divide them both by 2. That's how I got 1/5. All right, go ahead and try these 4 examples on your own. These 2 are using the power rule. These 2 are using the division. Let's review those 4 examples. So here on the first example, do not forget that the 3 has its own exponent, that 1. So because this 3 is touching the parentheses, we're using the power rule. Multiply with all the exponents inside. So that would give me 3 to the third power and x to the ninth. Now you can't leave your answer like that because 3 to the third power can be done. That's 3 times 3 times 3, which is 27. So we have 27 x to the ninth as my final answer. Now over here on the second example, these two exponents are touching the outside of a parenthesis. So those two get multiplied real quick. 2 times 2 is 4. And now that is what's going to be multiplied with all the exponents on the inside. So again, 1 times 4 gives you an exponent of 4 on the 3. And 4 times 2 gives you x to the eighth. Now the 3 to the fourth power can be done. That's 3 times 3 times 3 times 3, which is 81. So 81 x to the eighth. If you guys don't know what button to press for exponents, it's this button with the y and the x up top. So you put 3, touch that button, 4 equals, and it does it for you. So now let's move over to the division rule side. The first fraction there can't be divided because the top number is smaller than the bottom. So we need to simplify this fraction. 3 over 15 simplifies to 1 over 5. And now subtract the exponents. 75 minus 25 gives you x to the 50. Remember, all results go on top. And now, the right way to write that answer is x50 divided by 5. Or you can write it next to the fraction. 1 over 5, x50. Those are the two correct ways to write that answer. Now, in the last example, 15 divided by 3 can be done. So do it and put your result on top. So 15 divided by 3 is 5. X to the eighth divided by x to the first is x to the seventh. Now, because there's no fraction, no negative exponents, we're done. This is our answer. Any questions so far? All right, let's move over now to zero exponents and negative exponents. So over here, on the zero exponent side, I wrote it in words. Zero exponents turn the term into a 1. When a whole term turns into a 1, it disappears. So pay attention to the first two examples here, very important. X has a zero exponent. Anything to the zero exponent equals 1. That's it. That's your answer. There's no X there, nothing. Anything to the zero power disappears and it equals 1. Now, don't let me trick you on the second one. What has a zero exponent here? The X. But what's the exponent on the 6? A 1 always. So this is actually X to the 0, which is 1. And 6 times 1 equals 6. So be careful. Don't let them trick you by putting a number in the front. Whatever has a 0 exponent turns into a 1, but then you multiply. Teacher thing. Golo, I'm teaching an EOC review and recording it. All right, now let's do the second side, negative exponents. Pay attention here. This is very important. These two are easy to get correct unless you miss the explanation. So here on the first example, well, let's read the red first. Negative exponents move from the numerator to the denominator or from the denominator to the numerator. Why do you move them? To turn any negative exponent to a positive exponent. So let's draw a fraction line. X has a negative exponent on it. What number's next to X? A 1. Does the 1 have a negative exponent? No. So what has a negative exponent moves to the bottom, and now it becomes positive exponent. And then whatever didn't go to the bottom is still on top. What didn't go to the bottom? The 1. Mm, That's it. Yeah. So like for example, let's say you had here x6, y negative 5, and here you have z negative 3, d5. Right? What has a negative exponent? This one and this one. How do you make them positive? By moving this one to the bottom and this one to the top. If you move it, it turns positive. That make sense? Yes? All right. So here, look at example number 2. Again, the negative exponent is only on the x. The 10 has an imaginary 1 in there. So here we got x to the negative 3. Put a fraction, move it to the bottom to make it x to the positive 3. To the bottom. And now what stayed on top? The 10. So far, so good? Now, there's two ways of doing this. I want to show you both. On the first one, this exponent is touching a parentheses. So that means you have to multiply with the exponents inside. So that would give you 10 to the negative 2 and x to the negative 2. Because they both have negative exponents, they both go to the bottom. 10 to the positive 2 is 100. X to the positive 2. If there's nothing else left, what goes on top? A 1. That's one way of doing it, right? But look how much easier my other way of doing it is. Now, what has a negative exponent attached to it right now? The entire parentheses does because the negative 2 is next to it, right? So you know that this right here is 10x over 1. Let me teach you how to make a negative exponent a positive exponent if you already have a fraction. Just flip it. So if you put 10x to the bottom and you put the 1 to the top, that negative exponent turns to a positive exponent. And now you can multiply all the exponents by positive 2. You with me? Which gives you the same answer before. 1 over 100 x to the second. So, just to make sure you understood what I just said there. 2 over 3 to the negative 2. How can I make that negative 2 a positive 2? What? No. How can I make 2 over 3 to the negative 2 a positive exponent? I just said it here. What do we do to 10 over 1? I flip it. So 2 over 3 flipped is 3 over 2. If you do that, that becomes a positive. Isn't that easier to do now? 3 to the second is 9. 2 to the second is 4. Yeah. You with me? So it's just a little shortcut. You could always do it the long way. It doesn't bother me. Whatever way you think is easiest for you. All right, so I want you to try the 4 questions on the bottom on your own. I'll give you a full like 8 minutes for it because they're a little bit longer. Go ahead and begin. All right, on the first one, don't let me trick you. These two numbers are touching the parentheses, which means they get multiplied. So 0 times 3 is what? 0. Now, since it's touching the parentheses, it gets multiplied by all the exponents inside. So you have 10 to the 0 and x to the 0, because 0 times anything is 0. What is that equivalent to? 1 times 1, which equals 1. So because everything had a 0 exponent, it turns to a 1. And anything touching is being multiplied. On the second example, x to the 0 turns into a 1. But don't forget, thank you, thank you. Thank you, I appreciate it. What? You're welcome. All right, eyes up here, please. So on the second example, x to the 0 turns into a 1. Now that 10 has no 0 exponent. It has a 1 exponent. So what we have here is 10 times 1, which equals 10. They said happy birthday because my birthday was Sunday. So now here on the second side, on the negative exponents, thank you. What is the rule with division? Subtract the exponents. So 7 minus 17 gives you x to the negative 10. You can't leave negative exponents. So do a fraction line. How do we put a negative exponent and turn it into a positive exponent? By moving it to the bottom of the fraction. If there's nothing else left, what goes on top? The 1. Now, on this last example over here, 6 can be divided by 2. And remember, all results go on top. So 6 divided by 2 is 3. And x10 divided by x20 is x to the negative 10. Because 10 minus 20 gives you negative 10. Now, you can't leave your answer like that because there's a negative exponent. So your answer has to be 3 over x to the positive 10. Negative exponent goes to the bottom. So far, so good. Any questions? All right, let's move on to the next page. Very, very simple one unless you missed the explanation. So please pay attention here. So here it says, write a relation between x and y. This is a little hint I give you. Put an equal sign between the x and the y. So we read x to the power of 6, which looks like this, and y to the power of 7. Just make them equal to each other. And now I'm going to show you how to get a variable by itself in this situation. So watch what happens here. When you get an x by itself, something like this, what's the exponent on your x? 1, right? So when I say get the variable by itself, I'm really telling you make sure that variable has a 1 exponent on it because that means it's by itself. You with me? So how would you make a 6 a 1? By multiplying it by the opposite of 6, 1 over 6. So whatever number that is, multiply it by 1 over that number. And now whatever you do to one side, you have to do to this side too. This is going to give me my answer. X equals, because that cancels, 7 times 1 over 6 is 7 over 6. Now, because we see it's this simple, let's use a shortcut on the second question. You have x to the 8th equals y to the 2nd. Let's look back at what happened here. What happened to this number? It became a denominator on the other side. So we're going to already put the answer here. X equals y to the 2 over what? I repeat, what happened to this 6? It became a denominator on the y. So what's going to happen to this 8? It's going to become a denominator on the y. So this is your answer as long as you simplify it. So here we have x equals y to the 1 over 4. Because 2 over 8 simplifies to 1 over 4. You with me? Now, long way or shortcut, I don't care, but do these two examples on the bottom. You have a question? Correct. Put this one as your denominator. That's it. And why can we do that shortcut? Because we know what's going to happen if you multiply them by 1 over 6 or 1 over 8. So go ahead and try it. The 2 on the bottom. So on the first on your own question, you have x to the power of 7 equals y to the power of 6. So again, this number becomes a denominator on the other side. So we have x equals 6 over 7 as an exponent on the y. It is that simple. Now in the next example, we have x to the power of 2 equals y to the power of 8. So we get x equals y to the 8 over the first exponent, 2. Now 8 divided by 2 equals 4. You have to simplify it. So my final answer is x equals y to the 4th. Any questions? All right, let's move on to the next page. On the next page, these are division problems, but they have to do with negative exponents. And two things I want to make sure I clear up on this section. First thing is, on this section, they're going to tell you no negative exponents, which means you need to simplify this by getting rid of all the negative exponents. Now, I already told you how to get negative exponents to positive. Move them to the other side of the fraction. So the first thing we do is subtract exponents. So we get 3 minus 1, which equals x to the 2nd. We get 5 minus 10 is you y to the negative 5. And 10 minus 1 gives you z to the 9. Now, whichever one has a negative exponent, put it to the bottom of the fraction to make it positive. Whatever didn't move to the bottom is still on top. So bring it there. It's x squared z9. So what's going to happen on these questions? They're not going to make you write all this out. What they're going to say is simplify it, and then they'll ask you a question like this. What is the exponent on the y? What are you going to answer? 5. Now, if you say -5, you would be wrong because it says no negative exponents. So keep that in mind. Your answer is always going to be a positive number for something like this, because when you fully simplify it, no exponents will be negative. So let's do the second example now, but this one I included negative values from the beginning. Why does that make a difference? You'll see. Because if you're subtracting, pay attention, Jordan, this is important. If you're subtracting, right, -5 minus 10, that means you add and keep the sign, right? So we get x to the -15. But what happens with the second one? You got -3 minus -10. Minus negative means there's two minuses touching. If you forget one of them, you get the wrong answer. So be careful with that. -3 minus -10 turns into -3 plus 10, which is +7. So we get y to the +7. That's where people usually make the mistake. And now here, z1 divided by z1 is z0. Anything to the 0 power equals 1, which means it disappears. So what's my answer going to be? Let's see. This negative exponent forces me to the bottom, and the y to the 7th is still up top. Pretty simple? Any questions so far? All right, so I want you to try these two examples, and then we'll move on to the radical section. Questions? So on the first one, remember, all results go on top. So even if it's a negative, you put it on top first, and then you can move them around. So 6 minus 10 gives you -4. 5 minus 1 gives you +4. And 9 minus 4 gives you +5. Now the only negative exponent is the one on the x. So we do a fraction line and put that to the bottom to make that 4 positive. The other two are still on top, so they stay right here. Now the second one, 10 minus 6 gives you x to the +4. 5 minus 4 gives you y to the +1. 100 minus 6 gives you z to the 94. But here's the thing. All of these have a 0 exponent attached to it because it's touching the parentheses. What's the power rule? You multiply with every exponent on the inside. So what happens if now every exponent is 0? What's my answer going to be? If every exponent turns into 0, because 0 times anything is 0, what's my answer going to be? 1. Anything with a 0 exponent equals 1. So they all turn into a 1. 1 times 1 times 1 is 1. You with me? So from the beginning, you don't need to subtract anything. Just look at the 0 and say, oh, my answer is 1. Now, before I move on to radicals, let me show you something. Let me show you the beauty of exponents here. All right, let me show you the beauty of exponents here. Please pay attention. Now, the beauty of exponents is that order doesn't matter. The order in which you solve this, pay attention, Jordan. The order in which you solve this doesn't matter. So if you want to use the division rule first, like we did, cool, you get the right answer. But if you want to use the negative rule from the beginning, cool, you get the right answer anyways. So watch what happens. If I want to turn every negative exponent to positive exponent, I move it to the opposite side of the fraction, right? Are you with me? So here you have negative 5 exponent. Where should it go? To the bottom. You with me? Here you have a negative 3 exponent. Where should it go? To the bottom. But it turns to a positive. And now these two are ones. They don't have to move. Are you with me? Now, on top here, we have just a 1 and y to the positive 10. Because y to the negative 10, you move it to the top to make it positive. Are you with me? So now, all you really have to do is subtract positive exponents from positive exponents. 10 minus 3 gives you y to the 7th. And then here you have x10 and x5, which is x15. You with me? So the order doesn't matter. If you wanted to use a different rule first, as long as you don't make a mistake on your rule, you end up with the same answer at the end. Okay? So let's move on to the radical side of things. As you can see, there's only 20 minutes left of class. That shows you this radical section is not a big section. It's a very easy section. So let me explain to you first how to turn a fraction exponent into a radical. Top in, bottom out. So the x comes over here in the middle, but the top number goes in as an exponent. The bottom number goes out here as a root. Done. Top in, bottom out. So now here you get a radical and you have to turn it into an exponential form. So we're doing the same thing, but you don't have any numbers here. So you have to always remember that if you don't see an exponent on the x, it's a 1. And if you don't see a number on a square root, square means 2. So that's going to be x to the 1 over 2. Top in, bottom out. Make sense? Top in, bottom out. Now look over here at the second example on the left side. Usually, I would say a radical times a radical, put them in the same radical. But that does not apply to numbers that have different roots. If this has a 2 root, that has a 3 root, you cannot put those together like that. But there is a way to put it together. You turn them into rational exponents, and then you use your multiplication rule. You left something here? Hi. All right. So, take care, Matthew. So here on the left, we have x to the 1 over 2. Top in, bottom out. Times x to the 1 over 3. 1 exponent, 3 root. Now, what's the rule with multiplication? What do you do with the 2 exponents? Add them. If you add this fraction and this fraction in a calculator, it gives you 5 over 6. Now, they want the answer in radical form. So now you grab that, top in, bottom out. Top in, bottom out. And that's the answer. Copy it down because we're about to do the same steps for the next example. Second example, top in, bottom out. So we have x to the 5 over 3 times x to the 1 over 3. Top in, bottom out. Now, what's the rule with multiplication? Add the exponents. If you add 5 over 3 plus 1 over 3, it gives you 6 over 3. Now, can we leave the answer with a 6 over 3 fraction? That has to be simplified. 6 divided by 3 is 2. So we get x to the second power. Hmm? No, because there's no other fraction there, and a root cannot go lower than 2. So if you do top in, bottom out, right, that would mean you have to put a 1 there. That doesn't exist in math. It's square. It starts with 2 because of the word square. And now the last one. Now look at the difference between this last example and everything else that we've done on this page. Everything else we've done on the page, you have an x and an x, x and an x, x and an x. On this one, it's an x and a y. Are you going to be able to put those things together? No way. So all they want you to do is to turn each one into a radical next to each other. So top in, bottom out, and your answer is going to look like this. This is how your answer is going to look. Let's fill in the numbers that go in there. X on the first one, Y on the second one. Now, top in, bottom out. So top number is the exponent, bottom number is the root, and we do the same thing for the Y. Top number is the exponent, bottom number is the root. That's your answer. It's easier than it looks. These are like skipping questions where you see it and you go, oh, it sounds hard. Skip. Don't skip this question. Top in, bottom out, you're done. Now, let's go to the next page. On the next page, we're simplifying these radicals. Now, each one is a little bit different for a reason, okay? So over here, what's the number in front of the radical? A 1. A 1 you don't have to write. So why does that make a difference? Because whatever I pull out of the radical has to be multiplied by whatever's out there. So when it's a 1, it stays the same. But with the 3, it's going to change. With the 5, it's going to change. So watch me do the first one. The whole point of simplifying radicals is to see what repeats twice so you can pull it out once. So 32 is what times what? 2 times 16. And 16 breaks down to 4 times 4. So we have 2 times 4 times 4. Now, I could break down both of those 4s to be 2, 2, 2, 2, but what's the point if they already repeat? If you see something repeat twice, take it out once. Now, because that's a 1 out here, 1 times 4 is still 4, so it's not going to change. Now, what's left in the radical? What did I not take out? What did I not take out here? The 2. So if it repeats twice, it comes out once. If it doesn't, it stays in there. Let's try the next one. 16 is what times what? I could put 8 times 2, but why don't I put 4 times 4 since it repeats? 4 times 4, because it repeats twice, it comes out once. But wait, there's already a 3 out here. What happens when there's 2 numbers out here? You multiply them. So 3 times 4 is 12. Is there anything else left here? No. So your answer is just 12. Question? 16 became 4 times 4. And because it repeats twice, it comes out once. And that's it. Now look at this next one. We got 5 square root of 12. Let's break down square root of 12 to 3 times 4. And now we can break down 4 to 2 times 2 and bring down your 3. So what we have is 3 times 2 times 2. Does anything repeat twice? The 2 repeats twice. It comes out once. There's already a 5 out there. What do? I multiply it. So 5 times 2 is 10. What's still in that radical? 3. Easy? All right. No OYO questions on that one. I'll give them to you as bell ringers next time I see you. So here, this is the last page. I want to make sure we get through it. So here, this is adding, second to last page, adding and subtracting radicals. Now, this is similar to what we've been doing all year in here. Collect like terms. But the difference is, when you're collecting like terms, you have to have the same variable and the same exponent. In this case, you have to have the same radical. Radical is obviously the square root. So here, we have radical 3, radical 3. Are they like terms? Yes, because they both have square root of 3. So if they're like terms, use the same method as you used before. Add or subtract, and the exponent or radical or variable stays the same. So here we go. 3 plus 10 is 13, and the radical stays the same, just like when you collect regular like terms. Now look at the second example. They both have square root of 6. Are they like terms? Yes, because the radical matches. So 2 minus 10 is negative 8, and square root of 6 does not change, because when you add or subtract, the radical doesn't change. You with me so far? Now, super important, pay attention here. Are these like terms? No, not right now. But square root of 27 could be simplified. So you need to simplify it and then check if it's a like term. So 27 is what times what? 9 times 3. And then 9 could be broken down to be 3 times 3. So bring your other 3 down. So we have 3 3's down there. 3 times 3 times 3. Now, does anything repeat twice? Yes, the 3 repeats twice. It comes out once. What stayed in that radical? What's still in this radical? This 3 right here, because these came out. So we have 3 square root of 3. Now, is it a like term with this? Yes, it is. 3 square root of 3 plus 3 square root of 3 is 6 square root of 3. Add the numbers, radical stays the same. If it repeats twice, it comes out once. So if it repeats 3 times, that's not twice. So there's still 1 left over. That's why there's still a 3 there. You get it? That's like saying square root of 8, right? 8 is 2 times 2 times 2, right? But you have to circle them 2 at a time. So if you pull out a 2, what's left in there? That lonely little 2 over there. You with me? So far, so good? All right, I'll give you like 3 minutes, 2 minutes to try these 2 questions, and then I'll explain them, and we're done with today's lesson. No, that's going to take too long. Last page. I'll give you those 3 as bell ringers too. So last page. A radical times a radical. Put them in the same radical. Yeah, these are 2 examples. Copy them, yes. So 3 square root of 6 times 2 square root of 10. What are the regular numbers on that problem? 3 and 2. Those follow regular number rules. 3 times 2 is 6. And now, this is where I always say, a radical times a radical. Put them in the same radical. So 6 and 10, put them in the same radical. 6 times 10. And now, keep breaking it down. 6 is 3 times 2. 10 can be broken down to 2 times 5. Now, does anything repeat twice? Because the 2 repeats twice, it comes out once. Oh, wait, there's already a 6 there. What do I do with it? Multiply it. What's still in that radical? What's still in that radical? The 3 and the 5, which is 15. That's it. This is how you simplify multiplication. So with multiplication, the radicals join each other, and then they keep getting broken down. Right? So what's the point of making this 60? That's that's like working backwards. The point is to break a number down, not build a number up. So never build it up to a bigger number if it can be broken down. So let's try that last one over there. 10 times 2 is 20. And square root of 3 times the square root of 9 is the square root of 3 times 9. Radical times a radical, put them in the same radical. And now keep breaking down the 9. 3 times 3 is 9. Bring down your original 3. Now, does anything repeat twice? If it repeats twice, it comes out once. If there's a 20 out there, what do I do with it? I multiply it. 20 times 3 is 60, and we still have that 3 in there. Remember, when you break things down, always choose numbers that repeat if possible. If you have square root of 100, why would you put here 2 times 50 when you can put 10 times 10 instead and have a number repeat? You understand? So it's your choice. You're not going to get the wrong answer if you use 2 and 50, but it's going to take you 15 minutes to do the same problem that I would do in 30 seconds because you chose that route. So whenever possible, use numbers that you know repeat. If you get 16, don't do 8 times 2. You understand? Do 4 and 4. If you get 64, don't do 2 times 32. Do 8 times 8. It repeats. You could take it out. So you don't have to break it all the way down to the end if you use the right numbers. Questions? All right, finish up these notes, submit them to Google Classroom. I'm going to put in the assignment right now. And only one of you turned in the worksheet that we did last class. One person in this whole class. So, videos online, worksheets on Google Classroom as well. Get the worksheet done. All notes for full credit. Assignments on Google Classroom, so go ahead and if you're here, you could turn in your notes. If you took down all the notes, put them in the bin.